Well guys, today we have a really special tutorial done by our senior backend engineer Xano. In this tutorial you will learn how to compress videos in AWS with MediaConvert. So if you will ever like to handle this internally instead of paying for a third-party tool, watch this tutorial. I hope you guys like it.
Hello everyone, welcome. In this tutorial, we'll show how to create a video compression service using Xano and AWS. I've prepared a small architecture diagram that clearly shows the project's end result. Let me explain. First, we'll use Xano to upload video files acting as our backend. We can use Postman or the AWS console for the S3 bucket we'll create. When a new video file is uploaded to an S3 bucket, this event triggers AWS Lambda. We'll also use CloudWatch to monitor logs and ensure everything works correctly. Lambda will call AWS MediaConvert to process the video and store it in the same bucket or a new one for the resulting file. In the next section, I'll explain the prerequisites and everything needed to create this architecture. Now let's create the necessary roles that the services will use. AWS Lambda needs a specific role to access the bucket, AWS MediaConvert, and logs. AWS MediaConvert needs access to the buckets to read and write the new file, so we need to go to the IAM service. You can go to the console and type IAM. This service will appear here. We enter, though I was already here. We go to the policies section. First, we'll create a custom policy. If you're not familiar with this service, you could read the docs or watch a tutorial for a deeper understanding of how it works. Basically, this service handles security, roles, and policies for services and users across the AWS platform. Now let's create a new policy. We'll create it using JSON without any filters. I've already prepared a pre-written JSON for this. I'll copy it and explain each statement's function. In the first case, we're simply granting permissions to create logs, to ensure the service is displaying everything correctly, and to debug any actions being performed. The second is called IAM pass role. It's an action named IAM pass role. In Lambda, when we create the function, we'll need to pass a specific role to MediaConverter. From here, we'll pass a specific role, and AWS must ensure this service has permission to pass that role. Let's go back. Now we're here. This name isn't set up yet. We'll copy it later. Or rather, we'll paste it later. Next, we have the MediaConverter role. We need full access to the service. If you think you need fewer permissions, you could customize this part more. But for this simple example, we're giving full access. So let's move to the next step. I think I can put the name here, right? Okay, let's click next. Now let's give it a name. It'll be Lambda Custom Policy. This is a policy we'll add directly to Lambda. So we end up here. Here's a review of everything we're granting access to. As I mentioned, we're giving access to watch logs, also to IAM to pass roles between services, and to MediaConverter for video processing. So we create the policy, and now we have that policy created. Now we'll create two specific roles. A policy is a set of rules for use in various roles. We've created a policy to avoid, well, to keep that abstracted elsewhere. Now we'll create a role with that policy. So let's create a new role. We'll put it here. In this case, this role is for the Lambda service. Let's give Lambda a use case next. Now we'll search for our policy. It would be custom Lambda custom policy. There are more options, but we'll just click next here. Let's give this role a name. It'll be Lambda custom role. That name works fine. So let's go ahead and, well, here's the preview. Let's create the role and we're done with that. Now we need a role for MediaConvert. MediaConvert needs permission to write to S3. So let's go to roles and create a new one. We'll specify it's for MediaConvert. Click Next. We can leave this as default. To save time, we'll leave it as default. It's giving access to Picatware, which we won't use, but S3 we will. We'll click Next to keep things simple. Here we'll name it MediaConvert Custom Role. You can actually name it whatever you want. Let's click on Create Role. Now we have both roles. We have the Lambda custom role and MediaConvert custom role. We'll copy the MediaConvert role as it'll be passed through Lambda. We need to go to the policy we created. Custom policy, here it is. Let's edit the JSON. In the resource for IAM_pass_role action, we'll change this ARN. I think we need to click Edit. Yes, Edit. Here, we're going to change this and put in the current one. This is the link to our role we created earlier. We'll pass this to MediaConvert service via Lambda. Now let's click Next. Save changes. Save changes. Okay, done. We now have all necessary permissions configured. In the next section, we'll create the Lambda and bucket. We'll connect it through S3's events. Continuing the tutorial, let's create our first bucket. We need to go to the S3 service. We click here, searching. Here, we'll need to click on Create Bucket. In Create Bucket, we enter the name. That's the only setting we'll change. I can put Custom Bucket Convert, for example. We leave all this as is, this too. This means it's blocked for public access. It's fine as we'll use existing policies for services to access the bucket. Also, each file must be digitally signed before public access. This is crucial if we don't want to serve content publicly. So this setup is fine. We leave it as is. I won't change anything here. So let's click on Create. The only thing I've changed here is the name. Okay, we have the bucket right here. And that's it. We now have access. Next, we'll set up the Lambda function. We'll explain that in the next section. Now let's create the Lambda function. First, we need to go to the service. In this case, we search for Lambda and select it. In this dashboard, you'll see the option to create a function. Here we'll enter the name, for example, Lambda convert function. Something simple. For this example, we'll use the latest Python version 3.13. We'll keep the architecture as is. Now for the role, we'll assign the one we created earlier. Let's search for it. Since I only have these three, we'll use this one I showed before. Let's check if we have an initial configuration. No, it's fine. Let's click on Create Function. Now we'll create folders for original and converted videos. I'm in the bucket, so I'll click Create Folder. I'll create my first folder, for example, raw videos. Raw videos, then create folder. And a new folder that's also converted. Videos. Okay, let's click on Create Folder. Now let's link it to the original element. 3 events with Lambda, the function we've created actually. First, let's go to the Lambda function. In fact, I'm already here. You just need to go to the service. In the dashboard, you'll find your function. Inside, you'll see some code because Lambda provides a base function. Here, I'm going to print the event just to see its structure and work with it. Let's hit deploy. Now in the bucket, we'll go to properties and set up the event. We'll look for event notifications, create event notification. New video, for example. A simple name. The prefix will be raw videos. Everything in raw videos will trigger an event to Lambda. I'll use all object creation events. All events, rather. I want it to react to PUD, post, copy, and completed multi-part uploads, which is how large videos are handled in sections. So we've got all this set up now. We won't leave this suffix like this because we're not sending text files or anything similar. Just videos. Nothing else. We'll leave it at that. The Lambda function. Now let's specify which function it'll work with. We'll use the Lambda convert function. It'll go directly to a Lambda. You can connect it to an SQSQ or SNS messaging system, depending on your needs. In this case, connecting it to the Lambda function is most direct. Let's save it. Once created, the event should appear in the events section. Here we have a new event for raw videos. With Lambda configured, we can now monitor for any activity. In fact, I can refresh here. The S3 link should now appear. In this architecture diagram, it's already connected. Now let's test that event to see how it's coming in. Okay, I'm now inside the raw videos folder in the bucket we created. We'll test the configured event with a new file. Here I have a test video file. We'll leave everything as is, just upload it. Okay, it's uploading now. It's a small file, so no problem. Done, it's uploaded. Now that it's uploaded, let's go to the Lambda function. We were already in the code section. We have the event print, but if you don't, you can add it. This will just print the event coming from S. Then we'll go to monitoring to see the log from that print. Let's go here and check the log. We'll close this. That file upload triggered an event activating the Lambda function. And Lambda successfully executed the code. And since we've put an event print in the code, it's been printed here. Now we're going to enter this log sequence. Inside, we'll be able to see the log of everything. In fact, here's the print I placed. I now have the structure complete to know how to handle each action, or each action I'll accomplish here. In the next section, I'll show the finished code, but I'll go step by step so you can understand it. You can implement it based on this event. Depending on when you watch this, the event might have changed, so you may need to adjust the script. Okay, once we have the event here in the log, well, I've copied it here. As you see, this is an object with a records key inside. Records is an array of objects, each object being a record. That is a record, a newly uploaded file. Why is this an array of objects? Amazon S3 may group multiple files uploaded simultaneously or close together into a single event log. So we might have information about more than one uploaded file here. It's important to keep this in mind. Now let's briefly explain Amazon MediaConvert. Amazon MediaConvert is simply an Amazon service that processes video. It's very straightforward to use in this case. Since we'll run MediaConvert from Lambda, understanding how it works is crucial. This service operates through jobs. You can create a new job, for example. I have several test jobs I've tried before. You create a new job, give it input, specify the process for the file, and it provides output and completes the task. It stays idle until a new job. Because of this, it also has job templates, which are pre-established workflows. To generate this JSON, use online resources or your audio-video expertise. Basically, in job templates, we can create a template. For instance, I'll add an output group, and in this case, I'll click here again. Notice it's already generated more configuration in the job JSON view. In my case, I just want my video to always use this resolution, have this Mac vibrate, and the rest is pretty standard. As you can see, we have destination and file input here. These values will be dynamically changed in the Lambda and customized for each file to send the job to MediaConvert. Next, I'll explain this prepared code and test an uploaded file and a converted file. Now let's look at the main Lambda function code. We have 3 functions as I've structured it, but the main one is this Lambda handler with 2 params, event and context. We'll only use the event, so we start with this part. First, I added a more descriptive print statement, then checked if records exist to prevent future code issues. I extract some environment variables. This environment variable is preset in Amazon. We don't need to define it. It gives us the current region we're working in. We'll set this manually and see its values later. Next, we initialize MediaConvert using the Boto3 library. Boto3 is a library provided by Amazon Lambda, so it's already installed. We don't need to install it ourselves, just import it. We then use the client function, passing MediaConvert as the service and the region as parameters. The next important step is to get the MediaConvert endpoint. This essentially brings us the following. We use the describe underscore endpoints function of the client we just instantiated to fetch a specific URL. MediaConvert needs this URL because it's an available endpoint Amazon provides to perform the job. Without it, MediaConvert can't perform any tasks and will throw an error. Note that executing this many times in quick succession will result in a too many requests exception. This is a security measure implemented by Amazon. So if you're processing multiple files at once, you'll need to implement logic to manage execution times and other factors. In this case, we're only testing with one file, so I'm not handling any of that logic, just making the call. Once we have the endpoint, knowing that the records come in the event, we essentially loop through the records one by one. In this case, I'm printing just to see the record in the watch log, and finally calling a function I've created called process_s3_event. I pass it certain variables, the record, destination URL I already have, the role, and the region. So now this is where all the actual work happens. Here, I first generate a UID and convert it to a string to pass as metadata to the task. We've seen that everything is configured in this job. In fact, I've moved this template to a separate file. Don't worry, this is local. The idea is to use it in the Amazon console, but I'm showing it here for better visibility. Let's continue. Here I have a simple try block to extract what I need to modify the job and send it to my convert function. Both the bucket and key, which is the full name, are here, all in a simple concatenation based on your needs. After that, having these values, I open the job.json file from the root, load it as JSON, and then load it and change some values. Remember, file input and destination were set as dynamic values. That's why we're now running this and dynamically changing that JSON just in memory, right? We're not modifying the template or anything like that. It's only in memory, as this object will be passed as the final config when creating the job. Anyway, let's continue. Then we created a new MediaConvert client with the endpoint URL, and now we're setting up the job. We pass the role that this job will use. In other words, we're giving MediaConvert the specific task, right? We're passing the role we configured earlier with IAM pass role action and permission to assign a role to MediaConvert. So since we have that right, we can pass the role here as a parameter as they've requested. The metadata, which is just an ID, is only for differentiation. Finally, I print job submitted successfully for and add the value. This is just something I've added. If the try block fails, I print an exception to see what went wrong. Next, we need to transfer this code directly to the Lambda function. It's easy to use as they've created a new editor to make new files. The Lambda function py is ready, so I just copied the tested code here. Then I created job.json and copied the content into it. After that, I deployed it, which is crucial. Without deployment, nothing will execute. And then, since we had a file and captured its event, we can create, let me remove this folder, I'll delete it as I just did a test. So, delete permanently. We'll delete this. Okay. Going back here, we had the raw videos folder. We'd already added a video. Since we'd captured that video's event, we can directly create a test here. I've already made one, but to show you how it looks, when you get a new one, I'll click edit here. All the data you had, all the event info you'd previously broken down, you can copy and paste here as it's basically the same. It should always have the same structure, so we can copy it here as a test. I named it test and saved it. After setting all this up, we need to configure the environment variable. Here we need two environment variables. For the destination bucket, we'll use the same one, not create a new one. Next, the media convert role. The media convert role can go directly here in the IAM service. We need to pass the role we created specifically for MediaConvert. We enter here, select MediaConvert, and copy the unique ARN. We copy it, paste it here, and save it. One more thing to do in this example code, increase the wait time. Go to general settings, as it might take a bit longer. I only set it to 10 seconds. Ideally, it should be quick, but that depends on your optimization. Now that everything's set up, I'll click test and run it. It's now running. We can see it's executing, and here it returned a 200. If I monitor here, I'll check CloudWatch logs and see the log from a minute ago, from this specific moment. Let's see what loads. It's 11:26, which is about 5 hours ahead if I'm not mistaken. That's correct due to UTC. I'm in Peru now, so that's why it shows that time. Here it is exactly. This is from just now, showing all the logs I added, and everything worked fine in the end. Now let's go to MediaConvert. To the service, if I go there and check the jobs, let's expand this. Checking jobs, there's one from this hour, 6. Well, here my time zone is set, but sometimes it's not. So here it's completed. How do I verify that everything ran correctly now? I'll go here to the bucket, right, for the upload, and here I have the convert videos folder. I already set this path here earlier in the directly in this part. You could convert it to various environments if you like. I just placed it as is, but it's essentially the same. So if we review, we see that the raw video is 10 megabytes and the converted video is 6.5 megabytes. If I click here to open, we see the button and we see that the quality is very good. I've barely lost any quality and we've saved half the space. This is very useful if you want to put it in a browser with many videos on one page to load. It's likely not as heavy and won't consume as much bandwidth, especially if you're expecting 1 million users. This example is very useful when you want to create a private service like this.
Mm-hmm.
'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's connect the service we've made in Amazon with Xano. 'All right, now let's c First, we need to create a new endpoint. Here I have an empty folder. I'll create a custom endpoint and give it a name. In this case, it'll be a post. I'm not using authentication now, so I'll save it as is. As input, it'll receive a file. Let's go to storage, then to file resource. In this case, it'll be a file. Well, the name is file. Next, we'll create a function to fetch the file info, reading it as an object, and get the data, name, etc. For this, we'll go to file storage and look for get the raw data from a file resource. We'll use the file as input, and I'll name the variable file_raw. So we'll use that here. Then we need to connect it with S. We can write an S3 function here, and we'll select upload a file. This requires certain parameters, so we need to set it up. It'll ask for bucket, region, key, secret, and the file key. It's best to have these values as environment variables. So for that, go to the left side, go to Settings. I'm already in Settings. In Workspace Settings, click on Manage. I've created some values already. For example, we have the bucket, which is the name of the bucket we're working with. In my case, it's this one. The region is the S3 region we're currently using for the bucket. In this case, it's US East 1. Then we need the key and secret, so we have to go to the IAM service. Let's look at IAM. Always use a separate user for these access keys, not the root user, as it has too many privileges. We don't want more privileges than needed, so I'm using my root user only for this test. In this case, I'm getting this warning. That's why I've created a new access key here. I'll copy the ID, which is the AWS key, and my secret too. Let's copy this. Okay, I've configured my environment variable. Now I need to pass the values here through this function. So, AWS S3 bucket in my case, the region, the key, and the secret. Let's scroll down a bit. For the file key, we need to pass the final path the file will have. We know we need to put it in raw videos. We'll concatenate a word for the file name. In this case, we'll use the concat function. For the name, we'll use file raw.name as it's what it brings, and we'll use a slash as a separator. So it'll be raw videos slash the file name with its extension. For input, the total file will be the file directly. The input won't be a problem. And we'll name it S3 response. I'll save it here, and now I can test this small input. Since I'll test a file I've already uploaded, I've cleared my objects. The bucket is empty to show the example. Let's go here. I'll click Upload, select my test file, and hit Run. As the file is quite large, it'll take a moment to load in Xano's dashboard visualization. However, it might be faster if you do it via Postman or directly from your file. All right, the endpoint has executed. As you can see, everything's going well here. So I can go to the bucket and verify the file upload. The original file was uploaded correctly, but the converted videos are missing. I need to check if CloudWatch worked properly. Now that we're in CloudWatch, we need to go to the log groups section in the CloudWatch service and find the lambda convert function, which is what it's called in my case. So I'll enter here. In the log streams, I need to find one matching the time I ran the function or uploaded the file. In this case, I uploaded these 10 minutes ago, so this is the matching timestamp. I'll enter this log stream to view the function's logs. Remember, with concurrent Lambda runs, you might see the same execution in one log event. A new one won't necessarily appear. There might be more events and logs from later executions. I'm only doing one here, so they're clearly separated. As you can see, the last message ended correctly. This means the job was sent to MediaConvert successfully. Now let's check MediaConvert. Well, I have it ready here. I've done the jobs. The last task time matches what I uploaded today. It's when I just uploaded the file and it's complete. If something fails, you can check the job for errors. Now let's go to the bucket, right? To see if the file's there. And yes, I have the folder and file. If I open it, it should work without issues. Perfect. Well, that's all from me. I hope this was helpful. Remember to comment with questions. I also highly recommend exploring and integrating more Amazon services because you can configure many things to your needs according to business requirements and application specifications. It's crucial to do this in every part you build on a platform. So now we have everything set up. The API is running smoothly. All right, that's everything. See you in the next video. Thank you.